This is Voyager 1, launched on September 5, 1977. Mission elapsed time, approximately 49 years. Current distance from Earth, over 25 billion kilometers. Current velocity, approximately 61,000 kilometers per hour. Voyager 1 is not in orbit around anything. It is not slowing down. It is on an unbound escape trajectory, a one-way path out of the solar system and out of the sun's gravity forever. Right now, at this very moment, it is the most distant human-made object in existence. But distance in this story is only the beginning. The real question is this: how far will it actually go? And the answer is almost too large for the human mind to hold. Before we can answer that question, we need new units of measurement. Kilometers stop being useful very quickly out here. So does the astronomical unit, the average distance from Earth to the Sun, about 150 million kilometers. Voyager 1 is already more than 165 astronomical units from the Sun. Even that number becomes small very fast. So scientists use light years instead. 1 light year, the distance light travels in a single year, moving at nearly 300,000 kilometers per second. That is roughly 9.5 trillion kilometers. Voyager 1, moving at its current speed, covers 1 light year in approximately 17,000 years. Hold that number in mind, 17,000 years for 1 light year, because everything else in this script will be measured against it. Voyager 1 is not heading toward any particular star. It was never aimed at one. Its trajectory was set by a series of gravity-assisted flybys, Jupiter, then Saturn, each flyby bending its path and adding velocity, like a slingshot made of gravity. By the time it passed Saturn in 1980, its course was fixed. From that point forward, no further course corrections were possible. Voyager 1 is now moving in the general direction of the constellation Ophiuchus, as seen from Earth. It is heading up and out of the plane in which the planets orbit the Sun, angled above the ecliptic, climbing slowly away from the flat disk of the solar system. It will not pass close to any star for an extremely long time. Space, even within our own galactic neighborhood, is mostly empty. The average distance between stars near our Sun is measured in light years, not kilometers. So for a very long time, Voyager's path will be nothing. Emptiness. Darkness with no stars nearby at all. According to trajectory calculations by NASA and JPL scientists, Voyager 1's first notable encounter will not happen for tens of thousands of years. In approximately 40,000 years, Voyager 1 will pass within about 1.6 light years of a small star called Gliese 445, located in the constellation Camelopardalis. 1.6 light years may not sound close, but on a galactic scale, that qualifies as a near approach. For comparison, 1.6 light years is roughly the same distance as our own Sun's nearest stellar neighbor, Proxima Centauri, is from us today. Voyager will not stop there. It will not slow down. It will simply pass by, silently, continuing on into the darkness beyond. By the time this encounter happens, Voyager will have been completely silent, completely powerless, for tens of thousands of years already. No instruments recording, no signal transmitting, just a cold, drifting shape, moving through the dark. Before we go further into the future, a checkpoint. Voyager's power comes from a radioisotope thermoelectric generator, a device that converts the heat from decaying plutonium-238 into electricity. That power output decreases by about 4 watts every year. Mission engineers have already begun shutting down instruments one at a time to conserve what remains. Current projections estimate that Voyager 1 will lose the ability to power any scientific instruments by the end of the 2020s. Shortly after that, it will lose the ability to transmit any signal at all. At that point, contact with Earth will end permanently. Voyager will become exactly what it always was underneath the electronics, a piece of metal moving through space, obeying only the laws of physics. No longer a mission, simply an object, drifting. Let's return to the timeline. In about 40,000 years, the Gliese 445 flyby occurs, as described. Around the same general era, on a cosmic timescale, Voyager 2, its twin, launched just weeks before it, will make its own distant passes near other stars, following its own separate trajectory, angled downward and out of the plane of the solar system, roughly the opposite direction from Voyager 1. Both spacecraft moving apart from each other now, each carrying its own golden record, each heading toward a different, empty region of the galaxy. Neither will ever return. Neither will ever stop. There is no friction in interstellar space, no air resistance, no force acting to slow them down. The laws of motion that Isaac Newton described centuries ago apply here with perfect, unbroken precision. An object in motion stays in motion forever unless something acts upon it, and out here, nothing will. As the timeline extends further, precision becomes harder to calculate. Small uncertainties in a star's own motion, magnified across hundreds of thousands of years, produce large uncertainties in exactly which stars Voyager might approach and how closely. But the broad picture remains clear. Over the next several 100,000 years, Voyager will continue its slow drift through the Orion Arm, the same spiral arm of the Milky Way that contains our own Sun. It will not travel through any dense star cluster. It will not encounter any nebula up close. It will simply continue, drifting through mostly empty space, occasionally passing within a light year or two of some anonymous star, then continuing on into the dark once again. Across this span of time, human civilization itself will have changed beyond recognition many times over, if it continues to exist at all. Voyager will not know this. It will not know anything. It will simply continue moving, exactly as it has since 1977, carrying its golden record in complete, permanent silence. Zoom out further, and a different kind of motion becomes visible. Voyager is not only moving away from the Sun, it is moving with the Sun and with the entire local region of the galaxy in a long, slow orbit around the center of the Milky Way. That full orbit takes somewhere between 220 and 230 million years. Voyager, having broken free of the Sun's gravity, will still be swept along in this same broad galactic motion, tracing its own slightly different path around the center of our galaxy again and again, for as long as the galaxy itself exists in its current form. Across millions of years, Voyager will complete pass after pass through the spiral arms, drift through regions where new stars are forming, and regions where old stars have long since faded and died. It will not be affected by any of it directly. It is too small, too fast, too far from anything to be pulled in by any single star's gravity. It will simply keep moving, indifferent to the drama unfolding around it, new solar systems forming, in the same slow, patient way our own once did. Now, we reach the outer edge of what can even be reasonably estimated. Some models suggest that after roughly 4 billion years, there is a small, non-zero chance that Voyager 1 could drift near the outer regions of the Andromeda Galaxy, the large spiral galaxy currently on a slow collision course with our own Milky Way. But this is closer to speculation than prediction. Over billions of years, so many small gravitational nudges accumulate that no computer model can trace Voyager's exact path with real confidence. What we can say, with far more certainty, is this: Voyager will still be moving. The Sun, our Sun, will have exhausted its hydrogen fuel by then, swelling into a red giant and likely destroying Earth in the process. Voyager, already billions of kilometers away long before that happens, will be unaffected. It will already be somewhere else entirely, drifting silently among stars that do not yet exist today, carrying a photograph of a pale blue dot that by then will no longer exist at all. So, how far will Voyager go? The honest answer is, there is no final number. There is no destination, no arrival. Voyager was not sent to reach somewhere. It was sent to leave. And once something leaves, with nothing to stop it, it simply continues. Forever is not a word scientists use lightly, but in this case, it may be the most accurate one available. Long after every person who built Voyager has been forgotten, long after Earth itself has changed beyond recognition, long after the Sun has swelled and dimmed and gone quiet, Voyager will still be out there, small, silent, moving, carrying a golden record that no one may ever play, a message sent with no guarantee it will ever be received. And perhaps that was always the real mission, not to arrive somewhere, but to prove that we tried to reach beyond ourselves, as far and as long as physics would allow.